Welcome, everyone. Today, we are going to demystify data modeling for extreme, and I mean extreme, performance with Amazon DynamoDB. If you've ever found yourself wondering how to build applications that can handle just massive scale without even breaking a sweat, then you are in exactly the right place. We're going to break down all the core concepts and patterns you really need to know.
So here's our game plan. We're going to kick things off with the fundamental philosophy of NoSQL. It's a real mindset shift. Then we'll get into the specific tools DynamoDB gives you. After that, we'll weigh a pretty critical design choice. And finally, we'll look at some super powerful patterns you can put into practice right away.
All right, first things first. To truly master DynamoDB, you kind of have to unlearn a key habit from the relational database world. See, instead of designing your data structure first, you need to start with the questions you're going to ask it. This is what we call the access patterns first mindset. So why even make this shift? What's the big deal? Well, just think about a traditional relational database for a sec. As your application grows, you get more tables, way more data, and your queries, they often need to combine information from all these different tables. These join operations, they become incredibly expensive and just slow. They create a huge performance bottleneck. And this right here is the crucial shift. Instead of designing a perfectly normalized schema and then writing your queries, you flip it completely on its head. You start by defining the exact questions your application will ask the database. Those are your access patterns. Then you model your data specifically to answer those questions in a single trip. You're basically pre-joining your data into the exact shape your application needs it. Okay, now let's look at the two most important concepts you absolutely have to grasp to model data effectively in DynamoDB. These are the fundamentals of any DynamoDB schema. First up is the partition key. The best way to think about it is like the main address for your data. DynamoDB hashes this key to figure out which physical server to store your data on. And that's why choosing an attribute with high cardinality is so critical. Cardinality just means having a wide variety of unique values. Think user ID instead of a simple status like active. This ensures your data and all the requests for it are spread out nice and evenly, which prevents those nasty performance bottlenecks. And working right alongside the partition key is the optional sort key. What this does is it organizes items within the same partition. This is how you can efficiently model those one-to-many relationships, like all the messages in a chat room or all the products in an order. And then you can run these really powerful targeted queries on that whole group of items.
So, with those building blocks in our back pocket, we arrive at your first really big design choice. Do you put all your different kinds of data, users, products, orders, the whole shebang, into one giant table? Or do you separate them out, kind of like you would in the relational world?
The key thing here is that there's no single right answer. It's a classic trade-off. The single table design is what you'd call the DynamoDB native approach. It's incredibly fast because you can grab different but related items, like a user and their recent orders, all in one go. The downside? It's got a pretty steep learning curve. On the other hand, a multi-table design feels a lot more familiar for relational developers, but it pushes all the work of joining data back onto your application, which can mean more round trips to the database, higher latency, and more cost.
Okay, this is where the theory gets really fun. Let's look at a couple of super clever patterns that leverage DynamoDB's core concepts to solve some very common and often very challenging modeling problems.
First up is the composite sort key. This pattern is a really cool trick where you combine multiple pieces of information into a single sort key. You're essentially creating a hierarchical address for your data, which lets you make incredibly powerful and specific queries.
Check out this e-commerce example. The partition key is just the user ID, but look at the sort key. It's a composite string that includes the item's status, either active or saved. This is just brilliant, because now, to get everything in the user's active cart for checkout, we can run a single, highly efficient query that just asks for sort keys that begin with cart/active. So the really crucial point here is the incredible query flexibility you get. You're encoding hierarchical data right into the sort key. This lets you group related items together and pull out exactly the subsets of data you need without wasting a single read operation. It's so efficient. All right, next up is a totally different kind of challenge. What if you need to find that one needle in a giant haystack? Imagine you need an index on an attribute that only exists on a tiny fraction of your items. This is where the sparse index pattern just shines. In this IoT example, you've got millions of devices all reporting their status as OK.
but only a few are reporting a fault. Notice that the escalated to attribute, it only exists on the fault items. So if we create what's called a global secondary index, or GSI, on this attribute, DynamoDB will only copy the items that have that attribute. That means the index will only contain those 2 fault items, making it incredibly small, super cheap, and really fast to query.
I mean, this is such a powerful and cost-effective tool. Because the index itself is tiny, you save on both storage and the cost of writes. It is the perfect solution for that classic needle-in-a-haystack problem, letting you find items with a specific rare status without having to sift through millions and millions of other records.
So, we've seen a mindset shift, we've covered the core concepts, and we've looked at a couple of powerful patterns. So how does this all come together in a real-world production application schema?
This is just a perfect example of a single table design for a social network. Notice how different partition key prefixes group different kinds of data. For user A, we can easily grab their profile info, but by querying for a partition key that starts with user A hash follower, we can get a whole list of all their followers. The structure is just incredibly flexible, and it allows the application to satisfy multiple, completely distinct access patterns from just one table, using these targeted, efficient queries.
And that really brings us to the final thought here. The principles we've covered, designing for access patterns, leveraging composite keys, using sparse indexes, these aren't just abstract ideas. They are the keys to unlocking a level of performance and scale that might seem completely out of reach today. So the question I want to leave you with is this: what data model is holding your application back?